Hello students. So we were dealing with the chapter aldehydes and ketones. Yeah. So we had covered most of the reactions. Another few reactions are remaining. One is beer vinegar oxidation is what we need to do. Followed by that we need to also discuss another reaction, that is the managed reaction. Okay. So let us start with the beer vinegar oxidation. Now, so beer vinegar oxidation. Oxidation. So the reaction of ketones with peroxyacids in acidic medium results in the formation of ester. So this reaction is referred as the Bayer vinegar oxidation. So commonly used peroxyacids are perbenzoic acid, perbenzoic acid, peracetic acid, trifluoroperacetic acid. Okay, hope you know what is this perbenzoic acid. So see, this is benzoic acid. This is normal benzoic acid. So what is the meaning of this perbenzoic acid? Perbenzoic acid means there will be one oxygen extra. This is perbenzoic acid. Peracetic acid. Hope you can understand what is peracetic acid. Trifluoroperacetic acid. Okay, these are the few peroxyacids that are used in this oxidation. Whenever a ketone is treated with trifluoroacetic acid, that means trifluoroperacetic acid, CF3, C double bond O, OOH. Okay, it results in the formation of ester. So ketones on oxidation with peroxyacids will give you esters. This reaction is referred as the Bayer vinegar oxidation. To quote some examples, acetone, when it is treated with peroxyacid, perbenzoic acid, peracetic acid, trifluoroperacetic acid, you get an ester. Okay. So if you have a cyclic ketone, like this, that also gets converted into an ester. Okay, and oxygen gets introduced here between carbon and this. Oxygen is introduced here. So there are five carbon and one oxygen. The ring becomes 6-membered. So this is a cyclic ester. Cyclic esters are referred as lactones. So if we have an acetophenone like this, you get an ester. Okay, so this conversion of ketone into esters by using peroxyacids is referred as Bayer vinegar oxidation. Bayer vinegar oxidation. Let us go through the mechanism of this reaction. Let us see the mechanism of this Bayer vinegar oxidation. So mechanism. So the reaction occurs in few steps. Let us discuss the steps one by one. So the first step, ketone The reaction is carried out in acidic medium. Protonation of this oxygen takes place. Oxygen contains lone pair of electron. So first the protonation of oxygen takes place. R, C, double bond O, OH plus R dash. Okay. Oxygen is positive charge. Double bond migrates here. There will be shift of the electrons, resulting in the formation of R, C, R dash, OH. This carbon carries a positive charge. Why? Because the electron moved here. Okay. So this carbon carries a positive charge. So there will be a generation of intermediate carbocation. So carbocation is generated. Now next step is nucleophilic attack of peroxy acids at the carbonyl carbon takes place. So this is now positive charge. So peroxy acid attacks this. So R, C, OH, positively charged carbon, R dash. So peroxy acid attacks. Okay, peroxy acid. I'll just write the structure of the peroxy acid. Okay, R. I'll take a general peroxy acid. R, C, double bond O, 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 H. I will just write it like this. Right? This will attack. So this oxygen is forming a new bond. So a new bond will be formed. The old bond should break. This hydrogen goes off, leaving the electron here. Okay. So it results in the formation of an intermediate like this. R, C, OH, R dash, this R dash. Okay. This one. O, O, C double bond O, R. R, C, R dash, OH. So this oxygen has formed bond. This proton goes off. O, O, C double bond O, R. Now, the next step will be the migration of a group takes place. Okay. A group migrates. Now the question is, which group generally migrates? If the ketone is unsymmetrical, I mean if the two groups are different, then more electron releasing group will migrate. So for example, if you have tertiary groups, secondary and primary, tertiary will migrate because electron releasing group. So the migration will be tertiary alkyl groups will migrate. If there is a secondary and tertiary, tertiary will migrate. If there is primary and secondary, secondary will migrate. So this is what will be the order of the groups. So the more electron releasing group will migrate. So among the aryl groups, so the migration capacity will be para-anisile group, para-toluene group will migrate, next phenyl group, and then para-chlorophenyl group will migrate. Okay, now, so here the migration, this group migrates. Okay, when the group migrates, it results in the formation of this compound. I'll just write it. So you have R, C, OH. Since this group is migrating, the carbon will be again positive charge. So O, R dash, right? It is a group again, so this bond should break. Right? Now, next step will be, since this is positive charge, this electron removes here to form R, C, double bond O, H plus O, R dash. We're getting this, right? So this is what happens. Right? Okay, the bond breaks. Now, ultimately, the product will be, so this is what happens. So this group, the third step will be the product. Just write the product. R, C, double bond O, H plus O, R dash. So loss of proton takes place. resulting in the formation of ester. Ester is formed. Okay, so this is the Baeyer vinegar oxidation. Baeyer vinegar oxidation, that is preparation of ketones. It is the preparation of preparation of esters from ketones. Okay, by using peroxy acids. See, the only thing that you need to concentrate is which group migrates. If the two groups are there, then electron releasing group will migrate. If there is a tertiary group, tertiary alkyl group, and secondary, tertiary will migrate. Then secondary, and then primary will migrate. Okay, now there is another important reaction that we need to deal is the managed reaction. That is another important reaction, that is the managed reaction. Managed reaction is also a very simple reaction. Aldehydes and ketones containing alpha hydrogen, aldehydes and ketones containing alpha hydrogen, or compounds containing active hydrogen, on condensation with formaldehyde and ammonia, or you can use primary or secondary amines, they produce beta amino carbonyl compounds known as managed bases. So this condensation is called as managed reaction. So this is a reaction between aldehydes and ketones containing alpha hydrogen. Let's take an example. I will take an example of an acetophenone. C6H5, C double bond O, CH3. This contains an alpha hydrogen or an active hydrogen. When it is treated with formaldehyde and ammonia or amine, primary amine or secondary amine, write it as NH, CH3. So condensation takes place. Resulting in the formation of managed bases. So what happens is here, just the condensation reaction. So it will be C6H5, C double bond O, okay, CH2, N, CH3. This is what is formed. So if I want to write a general reaction, R, C double bond O, CH3 plus formaldehyde, right? C double bond O, HH plus secondary amine. The product will be R, C double bond O, CH2, it will attack here, CH2, N, R. This is referred as managed bases. We call them as beta amino ketone, beta amino aldehyde, or a ketone will be formed. Okay, alpha, beta amino aldehydes or ketones are formed. This reaction is called as managed reaction. Okay, let us go through the mechanism of this reaction. So very easy mechanism it is, right? So first step. So you have taken an aldehyde and a ketone containing alpha hydrogen, and then you should use formaldehyde and then ammonia, or you can use a primary or a secondary amine, right? Now, so let us see formaldehyde first reacts. Okay, formaldehyde in presence of an acid catalyst, okay, condenses with amine to form an iminium cation. So what happens is here, first the secondary amine that you are going to take, that is NH, methyl group, double bond OH. Okay, first reaction between the formaldehyde and the amine molecule takes place. Okay, so this contains lone pair of electron it attacks this. CH3 twice is what I will write. Okay, nitrogen carbon bond, N, okay, N, C, this carbon, HH, OH. Okay, if you are getting confused, you can just this one bond. This is another CH3, right? Nitrogen, CH3, CH3, nitrogen and attach this. So carbon, double bond O, when it attacks single bond O minus, it will take up this proton to form OH. Okay, now this is what happens generally. Then in presence of an acid, the nitrogen gets protonated. You'll get this compound CH3 twice. Sorry, nitrogen doesn't get protonated. This lone pair of electron, they move here. Loss of OH as water takes place. First is nitrogen attacks this formaldehyde, resulting in the formation of this intermediate molecule. Then nitrogen contains lone pair of electron. You all know that in presence of an acid, OH gets protonated. When say OH gets protonated, it becomes a good leaving group. So when it moves here, loss of water takes place. Double bond CH2, positive charge, right, plus water. So it results in the formation of this cation. We call this cation as iminium cation. Okay, next what happens is here. Second step. The aldehyde or a ketone containing alpha hydrogen generates carb anion. So when there is an alpha hydrogen, then that alpha hydrogen can be removed easily, right? So in presence of a base, so they lose a proton there because the proton will be acidic in nature. Okay, acidic in nature. So what happens is it results in the formation of generation of carb anion is generated. So carb anion is generated. So what happens is here. So you have H, CH2, C double bond O, R dash. Okay, this is an active hydrogen. Abstraction of proton takes place. It results in the formation of this cation, CH2 minus, C double bond O, R dash. See, two different, so you are mixing three reactants here. So one is aldehyde or a ketone containing alpha hydrogen. Then you have secondary amine here, and then formaldehyde. First a reaction between amine and aldehyde takes place, resulting in the formation of iminium cation. Cation is generated. Whatever the ketone or the aldehyde part that you have used, it loses a proton, resulting in the formation of carb anion. Okay, now this anion is formed. Now in the third step, so here is an anion, and here there is a positive part here, electrophilic. So this attacks this. Okay, this attacks this. Okay, what happens you see here? So you have CH2 minus, you have C double bond O, R dash is what you have. Okay, plus we have this molecule, that is CH2 double bond, this molecule will have. So this attacks this carbon. This electron shifts here. So there will be bond between carbon and carbon. So this is generated, R, C double bond O, CH2, 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 N, CH3, CH3. Okay, this is the managed base. A very simple reaction it is. First, the reaction between secondary amine and formaldehyde takes place. Next, a carbanion will be generated. That carbanion will attack the iminium cation that is formed. Okay, this results in the formation of managed bases. Okay, students, these were the two important reactions. So, only thing that is remaining is we need to deal with the synthesis of coumarin as well as vanillin. Okay, these are the two important things that we need to discuss later. That will deal in the next class. Thank you.